So let's try applying this formula then. So we're going to look at example 1. It says find the volume of the solid generated by rotating y equals x squared. So that's that green parabola. We're going to rotate it around the x-axis. So we're going to rotate it around that x-axis like that little loop there. And we're going to do this between x equals 1 and 2. So that's the yellow area that we're going to rotate from x equals 1 to x equals 2. Now, when we rotate that area, we're going to end up with a shape that kind of looks like this. So I'm just going to draw my parabola here. Okay. And this area is going to be rotated. So we're going to generate a circle like this. So it's going to kind of look like this in 3 dimensions. Okay, so it's kind of like this bowl shape. So if you can visualize this, I've drawn another diagram here. So it's going to have this solid that's going to be generated as we rotate that area around the x-axis. So we want to find the volume of this. So we have to think of what this volume is going to look like. So when we take the cross-sectional slice of this like this, the area that we're going to generate is going to be a circular area. So we need to find out the area of that cross section. Well, to find the area, we need the radius. So we're going to use the height of that. We're going to use the height of that curve to figure out the radius of each of those slices. So that's going to be my radius. So the area, my area expression, is going to be based on pi times r squared. Well, r is the height of that curve. In this case, it's x squared, and then we need to square that. Okay, so that's my radius squared. If I want to calculate the volume of this, then I'm going to take all those slices and give them some thickness. So pi r squared, and again, my r is the radius, x squared, and I'm going to give it some thickness, dx. Okay, so I'm going to give it some dx thickness like that, and then I'm going to add it all up, and I'm going to do this from x equals 1 to x equals 2. My integral is in terms of x and dx, so I can do this. It's consistent. So I'm just going to go ahead and simplify from 1 to 2, x to the power 4 dx, and I'm just going to evaluate this integral by anti-differentiating. So pi x to the 5 over 5 from 1 to 2. That works out to be pi, well, 2 to the power 5 over 5 minus 1 to the power 5 over 5. And so that simplifies to 31 pi over 5. And since it's a 3-dimensional solid, the units are going to be units cubed. So there is the volume expression for this. And the volume is that shape that's been rotated, and it gives us kind of like this pedestal looking shape when we look at it in 3 dimensions. So this link also will get you to an app that will allow you to rotate these functions and to help you visualize what some of these solids might look like.